Hi, my name is Christopher Suh, and today I will be talking about automatically generating limericks using deep neural language models. Over the past several years, we have seen great advancements in pre-trained language models, such as BERT, GPT-2, and Elmo. GPT-2 in particular has shown that these models are capable of generating text at or near the level of human poets, and all of these language models have gone on to achieve state-of-the-art results on multiple NLP and NLU benchmarks. In addition, there are also open source tools such as Spacey that give practitioners and researchers the ability to push and keep pushing the envelope of what is possible in the field. However, although language models have come a long way, poetry generation and limerick generation have received very little attention during this time. We think this is important because if we frame poetry generation as a constrained text generation problem, then we can take this general framework for generating text under hard constraints and apply them elsewhere as well. The pre-trained language models that we talked about previously are incapable of producing poems by themselves because they haven't taken into account the hard structural and semantic constraints that we talked about during training time. However, neural language models have been shown capable of producing Chinese poetry, but Chinese poetry is a bit of a different problem than English poetry in that Chinese poetry seeks more to paint a picture of a scene rather than tell a story, which is what English poems tend to do. We also saw that there hasn't been a serious attempt at generating limericks automatically using NLP methods in the past 20 years, and so we wanted to tackle this problem. Our approach and key idea in solving limerick generation was to combine both GPT-2's language modeling flexibility along with hard constraints in the form of part-of-speech templates taken from human-written limericks. We also came up with a method of generating storylines given a prompt word so that as the language model fills in the rest of the poem, that it would stay on track with a sense of story and also satisfy the rhyming constraint of the limerick. And in addition, we also present a diverse trajectory search algorithm, which efficiently explores the search space of all poems and returns multiple diverse results. And so below you can see some examples of poems that were generated using our methods. Our storyline methodology seeks to pre-generate the line endings, which are then fed into our language model, and then the language model fills in the rest of the words. So the storyline method returns a set of 5 words, which correspond to the endings of each line of the limerick, and they must satisfy the limerick rhyming scheme. And we also try to encourage our model to pick words that are semantically related to the prompt word. And we model this using distance in the word embedding space. And then when we place these words at the ends of each line of the limerick, the model is able to take these words into account and fill in the rest of the words, in such a way that they all are somewhat close in the word embedding space to the prompt word that was given. And below you can see some examples of prompt words along with the storylines that are method generated. Our DTS algorithm is also one of the novel aspects of our research, and seeks to improve upon a traditional beam search because we found that a regular beam search suffered from a lack of diversity and kept outputting essentially the same poem with like 1 or 2 word differences. We get around this and encourage exploration of the search space by maintaining the best scoring poems from several sets of different templates, so that each template will presumably be fairly different from all the other ones and thus lead to different poems. And yet we can also keep the top scoring poems within each of those stratified layers, so that we have both good poems and a nice mix of diversity in the output. We also added the ability to dynamically create new templates and explore those template trajectories by using a template matching algorithm, which allows us to append part of speeches from other templates than the one currently being used, so long as all the part of speeches up to the current point match the current template. And below you can see an image that illustrates one example of how our DTS algorithm would run and explore the search space. we ran a version of the Turing test in order to see how effective these methods were. And so once we had generated many poems using our method, we automatically curated the best output poems using a combination of GPT-2 scoring of that poem along with a diversity score in order to ensure that none of the poems would be too similar. And then from those poems, we manually selected the best half and presented them to um, Amazon Mechanical Turkers. And the results reveal that although the poems that were actually written by humans tended to be more frequently categorized as having, as like the participants thinking that they originated from humans, our automatically generated poems were fairly frequently mistaken for human generated ones. We also ran an ablation study, and here you can see that of all the different combinations of storyline and DTS algorithm, single being not using DTS algorithm, the combination of DTS algorithm and storyline gives us the best scores in each of these different poetic measures fairly consistently across all of the different poetic measures. For future work, we'd like to improve upon our current methods by creating better scoring functions so that we're able to differentiate between good and great poems and not just good and great poems and bad poems, because we believe that this will allow us to keep only the great poems if we run into any and discard the good poems, because we frequently find that we end up with most of our poems being good but not great. We would also like to apply some of our findings to other forms of poetry, such as sonnets, in order to see whether this general framework of generating constrained text will be successful in those domains as well and can lead to many more poems in the future. Thank you for your time and for listening to this presentation.